Hello, I'm Eric Snodgrass, and thank you for watching this monthly in-depth ag forecast brought to you by Ag Carolina and Ag South Farm Credit. All right, we've worked ourselves into an interesting situation with respect to weather patterns. We're going to have to discuss this today. It's going to center around understanding the positional strength, movement, and eventually the setup of the Bermuda high as we go into summer. Now, right now, it's sitting over Nashville, and as a result, we're getting incredibly hot conditions that are throughout much of the eastern part of the United States. They were over a much broader area. At one point this week, we had 200 million people in the country under some sort of heat advisory. Right now, just as I'm recording this early in the morning on June 24th, we've got, the Carolinas, most of Georgia under some sort of heat advisory, and then you can see here in this part of North Carolina, we've got excessive heat watch, so extreme heat watch, excuse me. Now, all of this follows what was, take a look at this. And this is how things shaped up from mid-May to mid-June, right? Overall, we did not see long duration heat episodes throughout the Carolinas and Georgia. Now, I did get pretty hot the farther south you went and closer to the coast. So we are on the warmer half of the distribution there during that time. But it just shows you how quickly things can change in the southeast. Now, here's what I want to think about. Oftentimes we find ourselves in the southeast specifically begging for rain and then immediately begging it to shut off, or the opposite. We're looking for the rain to quit, and then the moment it quits, we're like, oh, bring it back, please bring it back. That's how quick the hydrologic cycle happens in the southeast, given your evaporation rates, given your proximity to the ocean, and given your influence of one of the most, or given maybe your proximity, I should say, to one of the most influential high pressure cells on Earth. It's called the Bermuda High. So just take a look at what's going on right now. If you step into the upper atmosphere, this is where I see things. Overall, throughout much of the Northeast, for a while, we've got a big area of high pressure. That's actually going to influence. You're going to see this as we go into the day tomorrow. Your storms tomorrow are actually going to be coming around the base of this, off of the Atlantic Ocean, out of the east. But to the north of it, take a look. There's a trough in the North Atlantic, another big ridge that's here over parts of Europe, and a deep trough into Russia. And this is just what we call a long wave pattern. There are big waves in the flow of the atmosphere rather than a lot of little short waves over the next 15 days. And that's sometimes what happens in summer. The atmosphere tends to lose momentum and lengthen out in terms of its waves. We call them Rossby waves, actually, named after the guy who discovered them in the late 1800s, early 1900s. But the idea here is that if these waves get stuck and they don't progress, we have a problem. So let's think about this. Right now, that problem's in Europe. Okay, look at this. See this big ridge that's sitting over Europe? It's getting very hot. That's the next 5 days. That's day 5 through 10. And even day 10 through 15, all the next 10 days, put them all together, look how hot it's going to be. And as a consequence of that, take a look at their precipitation pattern. There's the next 5 days. That's the next 7 days. And if we look just at day 4 through 10, broad, expansive area of dry conditions. And if you stitch the whole day, 10 days together, from Spain and France through the Alps all the way over to parts of Ukraine, even sections of Turkey all around the Black Sea here, very dry and very, very hot. Now in the United States, we have something going on too with this ridge. I'll let you looked at this image for a while there, right? Take a look at what's doing to our temperatures. There's been a major cool down in the plains. The plains had multiple rounds of incredibly severe weather. I could spend the next hour just telling you about the severe storms that went through this part of North Dakota, or the derecho we had earlier in the month that came through parts of southern Kansas, or the huge event that hit here and then hit here back, June 16th, if I remember correctly, the eastern Corn Belt derecho that turned into the nasty round of storms that moved into the east. But now the discussion's about this heat. And there's been a cool down here where the temperatures have dropped more than 30 degrees. But watch the east. This is today's highs on Tuesday. Tomorrow, we're still deep into the 90s. Heat index is much higher than that. That's Thursday. Friday. Now, it cools down a little bit, but that's just due to some cloud cover. I mentioned there's some storm activity coming in here. But that's Friday getting into Saturday, Sunday, and Monday. Monday being the last day of this month. And we overall hang on to these very hot conditions. So the question is, we're going to open this up to any sort of cool down or some return of moisture. So let's keep on the temperature thought process for a moment here. This is the next 5 days all put together. As we just lengthen this out to get out there today, 5 through 10, here we are. There's something in this pattern that you need to see. Do you notice this? and there's a little bit of cooler weather here. Now remember, cooler for July is still hot, but those two features tell me something about the position of the Bermuda High. Keep them in the back of your mind as we go forward. This gets us out to 4th of July. If we go then through the days following that, this gets us out to the 9th, right about here. We overall don't see any significant cool downs. So that means our evaporation rates are going to stay relatively high simply due to the higher temperatures. So we've got to have moisture getting back into place. Otherwise, we're going to end up back on this map. Now, this is the latest drought monitor, and it certainly shows drought issues in the southwest, the northwest, pockets of the western Corn Belt over right to nearly where I live. In fact, yesterday I was in Chicago. I was on a family vacation. I actually still am, but I had to take a quick work trip in the middle of it. I'm out in Salt Lake City now. I'll get back over here and then up to northern Wisconsin by tonight. It's going to be a busy day. But I'll be watching this map over the coming weeks to see if this changes at all. That's going to be a top priority. Okay, where are we right now with our month-to-date precipitation? We had a few very, very large rainfall events in the southeast that have got our statistics on the higher side of the distribution. Now you can see here why the drought monitor looks the way it does, right? And there's them drier pockets in through here and then the northwest. But overall, every climate reporting district I've got has a number that is in the top half of the distribution for the month of June. But a lot of this rainfall came in huge helpings. If I just take you back over the last 2 weeks, we've had multiple rounds of storms that have come through, capable of dropping 2, 3, in some cases more than 4 inches of rain. We've had flooding in parts of North Carolina. Look at some of these storm totals here. In Georgia, I have a good friend down here that lives in Baxley. His name's Rocky, and every time he's got a major storm system coming his way, he just sends me a text. He's like, hey, another round. Well, those texts as of late have stopped, and I'll show you why in just a few moments. But the reason they were so frequent was this. Now look at this carefully with me. Start in the Pacific. These are the winds in the low levels of the atmosphere. And when you look down there in the low levels at the composite mean, so the average where they've been for the month of June, our Pacific high has been there. Our Bermuda high has been centered somewhere here, but it's been very expansive. Okay? It's what's helped draw some of that Saharan dust across the open Atlantic. Have you heard a lot about that in your news? Not a big deal, but it's done some stuff to our upper air quality. But what this has done is this has kept the Gulf open. It's kept moisture coming through, and that's what's provided the energy essentially for these thunderstorms that have gotten into our area. Now, I told you at the beginning of this, the Bermuda High is the key in the story. And if it moves, we have to know where it's going, because right now, it's not in Bermuda. It's in Nashville. I mean, it's sitting right there. Now, there's still a larger piece of the Bermuda High here. In fact, we're going to talk about that little guy. There's a little disturbance in the mid and North Atlantic. It's a possible tropical system, but maybe more subtropical characteristic. But anyway, part of the Bermuda High is here, and a big section of it is broken off there. Okay, and that is what we're calling our Nashville High. Now, while we sit underneath this, we're dealing with incredibly hot temperatures, and there will be a ring of fire precipitation pattern. But see what it's done here in the last 3 days? I mean, through this morning, all of our biggest and baddest storms have rolled through here. I flew over them last night. It was pretty intense flying over those from Chicago to Salt Lake. But anyway, just take a look at this. We had a big storm system went through parts of Canada, which has been extremely dry. Remember the fires in Canada earlier in the summer? Well, they had a storm system roll through there that was helped by the fact that this big high-pressure cell has moved over into the Mid-South. Now, because of that, we've gotten hot, we've gotten dry. Our evaporation rates have been very high, up to 0.4 of an inch per day. I mean, that's high. That's very high. When you get temperatures approaching 100 degrees, you're going to evaporate a lot of water. There's been some isolated storms in this pattern, and we're going to ask ourselves, are they going to get back into Georgia, more into North and South Carolina as we go forward? But what's interesting is, earlier in the month when the Bermuda High was where it was, we had saturated soils. Look at that. Start June, our drought problems were here and in the Northwest. As we finish June, take a look at this. We're starting to see these drier pockets beginning to show up. Even though recently such heavy rain's gone through, the last 3 to 4 days, the lack of good flow has allowed for high temperatures, high evaporation. So I need to know where this Bermuda High is going to go. Now, in the meantime, I want to show you this. By the time you get just to tomorrow, just into the day on Wednesday, the Bermuda High doesn't move too much. But what's going to happen is we're actually going to get a system that comes around the back side of it here, or really, I don't know if you want to call this the back side, I don't care, this side of it, the east side of it. And our flow in the upper level is going to send a disturbance right over North and South Carolina, parts of Georgia. And as a result of that flow coming around the expansive high in this area, we got this risk of storms. So take a look at it. That is the day 2 forecast, which is July 25th, looking at the risk of severe storms. And most of North Carolina, South Carolina, parts of Georgia, even down here toward the Panhandle, has got some risk of some storms tomorrow. But watch where they're coming from. Ready? This is a zoomed-in version of the high-resolution NAM model over the southeast. As I play it forward, isolated storms. You're going to get isolated storms that'll pop in this heat. That just happens, right? But they're very isolated. So don't expect it to be right there, but there will be isolated storms. But I'm talking more about, let's get into Wednesday. Now watch. Here's Wednesday afternoon, evening. Did you see the storms blowing up right here on shore? There's an increase in friction as the air comes over the ocean, and then it hits the shore, which is, there's trees, there's houses, there's vegetation, sand, there's stuff it has to hit, which slows it down, which increases the frictional component, which forces the air to converge, and when it converges, it rises. So storms are going to fire up there, and they're going to move across North and South Carolina into Georgia. See that? Now, this model is not going to have the exact forecast of the coverage. It's not. I'm just going to tell you, if you are in this region, watch out tomorrow for the storms to be coming in from the east. And we're going to need this rain, honestly. We got to get some moisture back into the system. So let's get back on theme here, though. Bermuda High. Now, there's 2 pieces to it, one there and one there. We talked about that, right? This is an animation of where it's going to be going over the next 15 days. Now, you want to know what I'm most concerned about as I watch through this? I just want to know. I'm going to leave it right there. I want to know, does it stay somewhere here? Or does it drift over there or into the North Atlantic? Or does it drift back over to Nashville? If we see any of those pieces taking shape, this is going to start to really rob us of any sort of hope of getting rainfall. The Bermuda High needs to be near its home, closer to Bermuda, to ensure that we've got moisture coming through into the system. So what do we end up getting out of this? Well, here's the European model forecast. I want to show you the whole country through Wednesday. So look, there's your storm chances, right? Then we get out there Thursday, Friday, Saturday. There's still isolated storm chances through the weekend. But I want to show you something. Just in the next 4 to 5 days, where's the wettest conditions? They're here and they're here. That's the flow coming around the periphery of the Bermuda High. And this is going to be hitting some of the driest parts of the Corn Belt. So listen, the Corn Belt is likely going to get decent coverage of rainfall in the next several days, while the Cotton Belt, which was all the way down to 5%, just 5% of the Cotton Belt was in drought. Well, now we're starting to see very hot and dry conditions into this area. Now for us, we have isolated storms coming. The coverage is not going to be great. It's just not. We're not going to have the kind of coverage that we all want. And maybe it's easier to look at this in terms of a percent or anomaly. So wetter than average, drier than average. Here's your next 7 days. So you can see some Gulf moisture getting in here, but there's some concern that if these storms that come through, in the next 24 to 48 hours don't hit this area, that we could be overall drier. Okay, the wettest conditions run the periphery of the ring of fire, which again is just the edge of that Bermuda High. That's day 4 through 10. Put all 10 days together. And if the coverage isn't right, we start to slip into a bit of a flash drought scenario in places. In places, not everywhere. Some folks are going to catch rains. And you know how this goes. The Southeast defines precipitation disparity. You just have some pockets that continue to hit and other places that miss. Now, probability-wise, this is the chance over the next 10 days of grabbing an inch. So you can start to see that some of the models are lower probability here of getting an inch of rainfall. Well, maybe back toward the Appalachian Mountains or down toward, the Gulf Coast, we have better chances. Again, this is all a story of the proximity to the Bermuda High. Another way to look at it, this is the probability of staying under a half inch. And as you kind of stretch this out there, you just start to see some risk in this area and also here into Texas, stretching back up into parts of southern Illinois. So let's just keep this in mind. This is all driven by the position of the Bermuda High. Now, where is it again? Upper levels of the atmosphere. It's right there. As I play this forward, you start to see a little low that sneaks into Florida, gets right up there into the Gulf Coast. That's what helps this area stays so wet. That's by Friday. But as we play it forward, boy, the pattern is relatively stagnant, except for around July the 2nd trying to drop a trough in here. Now, we always want to know, as a trough gets dropped in, does that increase or decrease our chances for precipitation? What I see as the bigger feature is the fact that the atmosphere is favoring these long waves. And those long waves just tend to get stagnant, which means you tend to just keep getting more of what you've had. And if the pattern does become fully established like that, the week 2 forecast, which let's go out there and grab it real quick. There it is. Looks something like this. Now, it's interesting. Each model gives us a little bit different scenario. That's the AI model there, second in from the right. But the European, it's got storm activity in our region. And that's something I want to think about. Because overall, I didn't see the Bermuda High move so far away that there's a big problem, right? It seems to live nearby enough to drive in moisture. I told you it's not going to be equitable. It's going to be delivered in these thunderstorm events that are hyperlocal in their moisture delivery, but you're used to that. That's what you call summer in the southeast. But I want to get here. The newest outlook was just released, and this is what I like to focus on in these videos, from the Climate Prediction Center for July. And this tells me I had better find out where they're placing the Bermuda High. See that? They're above average for you. In fact, you are not on their seasonal drought outlook. You're not on their monthly drought outlook. They're suggesting that wetter than average conditions are here, while much hotter, drier conditions are going to hit big sections of the northwestern United States. Look at it again. Now, how do you get a pattern like that? How do you get wetter than average in this area? So I went out and looked it up. This is a time series for the southeast starting in July. For July, starting in 1895. What's interesting was, throughout parts of the 30s and 40s, we were wetter. We went drier in the 50s through the mid 70s, and since then we've started in the month of July a slight upward increase in total precipitation. Okay, that's what that blue line is. But I went through and I found these wetter Julys. And I'm going to say, well, what do those wetter Julys look like? And you might be interested to see this. You stitch them together, 13, 84, 94, 03. These are the wet ones up here. And it got really hot in the northwest. And we stayed near average to cooler than average here. See, this only goes to 2 degrees cooler than average. So we didn't see long duration episodes of excessive heat during these years. This is what the precip looked like. Notice there was kind of this tongue of drier conditions here while we were wetter in this area. Now look, this is what drives this pattern. Those Julys all put together, we had a big Pacific high there. There was a trough of low pressure here, and the Bermuda high was there. There's another piece of it, just so you see, that was all the way over into Europe, which made them pretty hot and dry. But if you keep the Bermuda high close to Bermuda, which is here, you end up getting flow around it like that. Now, the issue with this pattern is the jet stream goes over the top of this, and then it comes over and stays up there. And that's why this area gets drier, because all the moisture gets pushed there. You see, if the Midwest wanted to go wet, you take that Bermuda high here and shove it right over Georgia. Oh, that's perfect for the Midwest. But we're questioning whether or not that's going to occur. Because if you look at the pressure patterns, I'm just out here mid-July, look at the strength of the Pacific high. It's much higher over there. This is a pressure anomaly map, not temperature, pressure anomaly. So these are higher pressures and these are lower. Bermuda high, some of it's here, but there's still stronger pressure on that side. You're saying, well, what does all this mean? It means that the model's doing this. That's the prediction from the European model for July. What is it also doing? Wetter, drier, wetter. This suggests that the jet stream's ridging here, producing higher pressure in this area. We'll likely get storms that'll cascade off of this, that'll cut through this area. We call those ridge riders. They'll be right in that corridor. But overall, we have this chance of seeing a wetter July. Now, I expect it to be hot and I expect it to be stormy. I don't expect it to be cool, okay? If you take a look at the temperatures out that far, this is how it looks. You're going, wait a minute, that looks near normal. I understand. But I'm telling you, I still think we have plenty of reason to think we're going to keep it hotter. But the models keep doing this because of the drifting off of the Bermuda high, maybe more toward this part of the North Atlantic. And again, you see it. That's what the CPC is suggesting as well. So the European model and the CPC are kind of on the same page here. Now, let's go out and look out a little bit farther from this. This is the new July, August, September outlook from the Climate Prediction Center. Looks pretty similar, doesn't it? This is what they've got for August, September, October, still wetter. And where's the greatest heat for July, August, September? It's here, but notice they do have you hot. So I do think it's a hot and stormy summer. And this again is the August, September, October, or July, August, September, excuse me. Now, I wanted to go out and look and confirm this with some other models. This is the newest update from the European model, July, August, September. And again, more hot and stormy conditions here. Now, I had a friend text me late last night when I got into Salt Lake City. He's in Nebraska. And right now in Nebraska, the forecast is wet. Let me just show you this. I'll go back. Let's just pull this up. WPC. See that? And he says, oh, this is the kiss of death. And I said, what do you mean? He says, well, sometimes when we see the models forecast such wet conditions, when we need it, my brain says, oh, don't expect it. Just don't put your hope in something like that happening. He lives right here around Omaha. So when I show you these forecasts, you're like, man, at least it's looking pretty good. A nice, hot, stormy summer, plenty of water. No, we're not on the drought risk by the Climate Prediction Center. I mean, look, we're not even on it. So, hey, are we smooth sailing? Are we going to move out of here with good conditions? I'll be honest, it can all change in a heartbeat. Remember, in last month's video, did I tell you that the Bermuda High was going to go to Nashville? No, right? So all of these long-range projections are based off of some interesting things, like ocean temperatures. And one of the big reasons why they're floating the Bermuda High here is because there's been a surge of warm water there. There's still cool water in what we call the PMM region. There's been a little bit of an Atlantic Nina behavior. What is that? That's where the trade winds have been a bit stronger here with time. But we have this warm water over much of the Atlantic. You look at all these factors, even include La Nina into this. Yeah, we're still dealing with the remnants of a La Nina. There's been stronger than normal trade winds here for months. And it all just says, give them that configuration. But any shift in the forecast of that Bermuda High will change everything. So I am not settled on all of these forecasts like that one, or this one, or even the temperature forecast to be right. I'm very, very skeptical of it. But since we're talking about La Nina, I want to let you know something. The forecasts continue to keep INSO neutral, but I want to be on the lookout for by the time we get into late fall for this La Nina to maybe make another recovery. Some of our statistical models say that by the time we get into October, November, December, the highest probability is to be neutral, but there are some chances of La Nina making a return. And we have to consider what that might possibly mean, because if you correlate July to September with La Nina conditions, that's also another factor. We tend to be wetter here while this region tends to be drier. So can you see now how these longer range forecasts are looking at those ocean temperatures and the recent behavior of the atmosphere and giving us the forecast they did? But why I'm a little bit skeptical of this and why I think it's of concern is because we already right now are keeping an eye on a system way out here in the North Atlantic. It's subtropical in nature. The East Pacific has had multiple storm systems, but there's a lot of warm water in this area by which we could be thinking about the development of tropical systems. And this is where I think I want to finish. The Bermuda High position, by the time we get into August, September, October, will ultimately determine where these tropical systems are going to go. And if you look at the analog years that Colorado State is using, here they are, this does put the Southeast at risk for an active hurricane season. Now you're going, wait a minute, I don't see a whole lot crisscrossing. I know you don't. But look how close many of them were to the shore in these analog years. So we just need to be careful of getting some of these systems closer and closer. Right now, in every category, if the averages are here, this is the Colorado State University updated numbers, they're above normal. Now, they're not like as aggressive as we were a year ago, but they're above normal. And even the 2025 Atlantic hurricane season outlook from NOAA is above average. So we're trying to piece together these things and understand what the risk package is going to look like. And while there isn't strong evidence today that the Bermuda High is going to cause all sorts of problems all summer and into fall, I'm skeptical of where its position is going to be, and you should be as well. So let's watch it together, keep an eye on it, because it will ultimately determine how the moisture opens up to the southeast for Ag South and Ag Carolina. So I'm going to wrap this one up here. You now know what I'm watching for the next month. We'll talk again in July. Thanks.